there. Okay. Um, so I gave the talk yesterday, just to give an overview of where the DomB experimental implementation, a sort of research prototype, has gotten, um, and it raised quite a few issues in the stuff that was uncovered during the implementation, but also um, just trying to find out what other people's needs for this type of functionality are, to take into account with building something hopefully suitable for including in upstream Zen. So I just wanted to run through a few notes, to convey what it is we're trying to do, and the idea in the current structure. So we've got a bootloader that is loading the materials that we use to build an initial set of domains, multiple domains launched at host start. So it's the kernels and the RAM disk get loaded into RAM by the bootloader, along with some binary form that describes the domains that you want to launch. The hypervisor performs the domain construction, um, currently either PVH or PV, and when we get to looking at the ARM stuff, it'll be standard PVH. And then it'll unpause only a single guest, and the responsibility of that guest is to do any additional configuration, any measurements that you want to take before any of the other domains get to run, which is important for security, and allowing DomB to sequence the startup of the other domains, hopefully quickly. DomB itself doesn't have hardware access. The idea is that it is a limited privilege and most likely short-lived domain, exits when its work is done. And yeah, so I guess some feedback on whether that's a direction that is compatible with what people want. Okay, Jason, you got a question. Hypervisor constructs multiple domains or DomB only. The hypervisor actually performs construction of multiple domains. There's a loop in Start Zen where it is calling domain create and then doing domain construction so that the P2M table is done, the relocation of the kernel, decompression of the kernel, all of that's done by the hypervisor. The only thing that doesn't happen with that domain is it's not unpaused. And DomB does the unpausing. So the question, could DomB be used to explore hardware and create driver domain as needed? Yes, I think it could. It's more likely, though, that you would, as one of your initial domains, you would define that hardware exploring domain, so that all DomB has to do is a much simpler piece of work of unpause it. The reason is that I don't really want to turn DomB into a grab bag multifunction domain that kind of was the demise of DOM0. If we can keep DomB small and light and have other short-lived single-purpose domains, basically have a disaggregated system launch, I think in the long run that's going to be more flexible, allow things to be swapped in and out, components and VMs to be reusable. Does no hardware access imply no TPM access here? Possibly yes, it means no TPM access. I think the management of the TPM and the Zen platform is a complicated topic. I think people more familiar with the VTPM implementation should talk to this point if they can. I don't know if Jason or Daniel want to take that point. But I think having a TPM driver in Zen might be the way to get initial measurements into the TPM. Don't think it's an awful lot of code, and I also think that that code could get discarded the same way that the init logic in the hypervisor gets discarded. Okay. Bertrand, you're asking about kernel decompression. You don't get why it's done in Zen. It's not obvious why it's done in Zen. It is there. So if you boot with a compressed kernel, if you boot DOM0 with a compressed kernel, there's a bunch of inspections to see what type of compression is used. There's several decompressors that could be activated and decompressed within Zen. Now, it's possible that this is because it's support for a non-Linux DOM0. Linux is able. Okay.
So I can answer that specifically. Zen PV guests have various bits of the ABI in ELF notes, which means you need to decompress Linux to be able to read the headers to figure out what to construct. Also, if you don't decompress Linux, it will attempt to decompress itself in 16-bit mode, which also doesn't work great. There were a number of things, but yes, the main important one is we need to decompress at least the ELF header to be able to read the ELF notes.
Thanks, Andy.
And at that point, you might as well just decompress it all.
Yeah, in part of making my way through the implementation, it was a question that should this be done in hypervisor context? Would a short-lived guest context be a viable way to do that? I don't know. I'm interested and tempted to have a go at hacking that up.
I mean, yes, you can do that, but then you're adding quite a lot of overhead into boot.
Okay. Okay. Any further questions?
On the subject of a TPM driver in Zen itself, I believe that's going to be necessary for some of the DRTM stuff, is it not?
So,
I mean, at the bare minimum, we need enough logic to replay the TPM event log, and that's most of a TPM driver.
Okay, yeah. It's a simple enough device, and it's logic that can be discarded, once boot's done.
Yeah.
So, Andy, what is your take on the acceptability of using a dynamically detected toggle between booting DOM0 and booting with a launch control module? A reasonable thing to send upstream?
I think that's a reasonable thing to send upstream. Obviously, we want to be in a position where it's hard to accidentally misconfigure yourself and lose access to the system. From that point of view, having a default that is dynamic and can do both tends to be a whole lot better usability than not.
Okay. So the use of a Zen-specific binary module versus using a device tree, the motivation for that was partly to discover the set of data that needs to be conveyed just to start the initial set of domains. It looked initially relatively simple because you can look at the arguments to domain create, and those are the things that the hypervisor needs, not particularly verbose, and so that's what's captured in the version built so far. But once you get into things like guest vCPU bring up, there's quite a bit more configuration there. there's so it's a question of whether you actually end up saving an awful lot by having a Zen specific uh, binary implementation, or whether you might as well just take the hit of having a general device tree parser um, on x86 as well as on ARM. I don't have a sense for whether the ARM community would be receptive to having a Zen specific binary. Right.
Well, um, on ARM, we are relying on the device tree because that's the technology also used by the Linux kernel. So what DOM 0less is doing is just adding some extra nodes, but we don't need to change the device tree format for that. The format is generic enough so that you don't need to do any new implementation of the device tree itself.
I get that the device tree format is capable of carrying that extra information, but isn't the device tree sort of usually specific to the hardware, right? And once you've got set hardware, you don't need to change that tree. In fact, it should be usable with different kernels. Whereas, go ahead.
You can still add information to this tree, even though the complete hardware is described inside this device tree. There is already the code inside Xen to manipulate it, because on ARM, you generate a device tree when you start the guests, for example. So you have all the code to manipulate it, and there are tools to not rewrite the device tree, but add entries to them. For example, in U-boot, you can just say, I want to add a new node to the device tree, and you put there the Xen node, and you add what you need.
Right, like the overlay sections.
For example, yes. Maybe Stefano is in the call?
I'm here. So, so see, for device tree, I think, you have to think about each part as separate. Like there is a spec to describe the source format, the spec to describe the binary format, and then there is the convention, the device tree specification itself on how to describe the hardware. So the fact that device tree is typically used to describe the hardware doesn't mean you cannot use it to describe something slightly different. For instance, the device tree that we use for device assignment to the muse is its own little tiny device tree with just information on one node and a couple of special attributes. And that doesn't really look like any real, quote, real, end quote, device tree. So it would be, so one thing I would be curious about is how much of an overhead would be for you, if any, right? It might turn out there is zero overhead, but how much of an overhead would be for you to use a tiny device tree with just key value pairs and the same structure that you have today, but just in DTB format, using the libftt implementation already in Xen, enabling the build, and see how it goes. It could be that the overhead is close to zero. I mean, compared to what you have today, or very small. Yeah, because libftt, it's actually designed to be embeddable in a kernel, so it's small. It's not really a big library. Now, if we were talking about tiny application, and you want to go down to the last, byte to save memory, you would probably be able to do smaller than libftt, right? But we are still talking about, I don't remember how big it is, but few kilobytes, I think.
Okay, and is that a pretty static piece of code, or is that
It's very static.
Okay, and pretty widely deployed.
Yes, yeah, it's used everywhere. So that's one thing they did right about device tree. So it came with the reference implementation in libftt, and then they wrote libftt so that it could be used both on the build host as well as at runtime in the kernel. So libftt is basically used everywhere, from DTC to U-boot to Linux, Xen.
Okay.
I just want to say something is libFTT is not something that you can use on a non-trusted device tree. So if your plan is to have something that you don't trust on parsets, don't use libFTT.
Thanks, Julian. I see. Okay. And I guess a separate thing is one of the things that we've had to build in order to boot PVH x86 guests is logic for building ACPI tables. We were looking at using ACPI tables as a means of exposing the contents of the launch control module to a guest. And it seems like that might be rather foreign on an ARM platform, or is that not the case? Do you use?
There is a CPI on ARM now, so there is not that foreign. Unfortunately, I would like to say it's foreign, but no.
Yes, no, there is a CPI on ARM, so definitely, it's yeah, that would also fit. Device tree has lots of advantages. ACPI has also advantages. Right now, the device tree has some safety advantages because you write it yourself, you define what you want, and that's it. ACPI is you depend on some things which are code dependent, more or less. But yeah, ACPI is supported on ARM.
Okay. Okay. But another topic is in the prototype. Basically, we have XenStore running in a non-DOM 0. That's fine. You got so XenStore D. But when your initial domains come up, there's no backend for them to connect to. So we would need to start looking at making the tool stack, probably libxl, aware that some domains will be running before the tool stack environment actually boots.
I think you want to split that into two separate problems because they are slightly unrelated. Having XenStore as a stub domain is something that already exists. It's even got some token support upstream in Zen at the moment. I think Jürgen repeatedly hits it when it breaks, kind of thing. That is, but yes, I think it is there and working. That's separate to what XL and libxl as a tool stack expects, and at the moment it will complain violently if there are any unknown domains on the system, because it will try and look up the tool stack private data in /libxl /domain/type, find that's missing, and then tend to refuse to do anything further with the domain at that point. So that is something that has become less problem. That's something that has become more of a problem over time as libxl has gained more expectations that it knows about the full layout of the system.
Yeah, but
only if you actually want to use libxl, if you actually want to use libxl to control those domains, if the domains are on their own program and don't need to be controlled by XL, then it shouldn't be that much of an issue, right?
Yeah, I was gonna say, I think that is not really the major problem. So I looked into this for DOM zeroless, and I also could draw a kind of a plan, and in theory the implementation should come with this year. That's not quite confirmed yet. But for DOM zeroless, so the main issue is really not libxl. The main issue is really, and I think you're gonna find the same for you, it's the XenStore connection. So especially in Linux, the code to set up the XenStore connection is not really capable of waiting until the domain is up. it expects the domain to be up. And it's similar, especially in DOM0. I mean, both DOM-U and DOM0, but especially the DOM0 to the initial connection. I'm not talking about the XenStore entries. I'm talking the connection to the XenStore D. So that is, I think, the major thing that needs to be fixed.
What? XenStore stub-DOM is started by DOM0 some rather late in the boot process, and it's connected quite fine, so that's not a problem.
Yeah, it works fine in Linux.
All right, so maybe it's the DOM-U, but there is some of the waiting dependencies there. Let me look it up.
So there is definitely a problem with DOM0less, because from then you need to create the XenStore, and you need to start that domain, you need to wait on the events. So there is quite a bit of logic to add in Zen. This is much easier to do from Linux because you have already everything included in a user space to start a domain.
Yeah, but if you have DomB being capable to unpost domains, it can as well unpost a XenStore domain. That's a non-issue in my opinion. The problem is if you want to have PD domains in there needing XenStore. This is a problem because PD domains get the shared XenStore page and the event channel assigned from the hypervisor. And when there is no XenStore domain at this time, this is a problem, of course. So you would need to create those mappings for PD domain, those grant table entries for PD domains somehow in between. Maybe from DomB, okay, this is possible, but you need to do it.
Interesting.
I mean, it's not just PV domains. HVM's got the same problem. You still have there's less wiring up to do, but you've still got to set the HVM params correctly after you know what the bound event channel and grant frame that has been made.
So, yeah, and the DOM ID of the XenStore, of course.
Supposedly, when someone needs something like that, that means that there is a DOMD somewhere which provides a PV interface to a DOM-U, right?
No, I don't think so.
No, the hypervisor provides the PV interface, and the hypervisors build the PV domain, but DomB could set up the grant table entry needed for XenStore and the event channel.
So
Yes.
it would set up the initial status and then could die.
Right.
Okay.
So DomB itself would not need to have access to XenStore, right? It would just need to set up everything, and yeah, probably, each other domain booted this way, would it need to set up its, would those domains need to set up their own initial XenStore entries, or would this be some control domain doing that, or whatever? So this is, I think, this is a theoretical problem, but it can be solved, I think.
You need to know the XenStore DOM ID before you can create the event channels for any other, before you can create the event and the grants for any other domain to use.
Yeah, right. But if you can unpause the domain, you know it's DOM ID. Otherwise, you couldn't unpause it. So I think this is not an issue.
Right, but that still means you need to move part of the tool stack into DomB to list through all other domains and wire up the event channel. So at the bare minimum, you need evention alloc unbound with control domain privileges to be able to create an unbound event channel in a remote domain, and then fill those details in the shared info or the HVM params. And you need to be able to map the same domain's grant table to be able to write the grant table entry that will allow the XenStore domain to map the shared ring.
Right.
So I think that's how it currently works. I certainly have some plans to try and remove some of that complexity in the HVM ABI v2, but we probably don't want to merge all of this. At which point we should try and look at the complexity here and reduce it, because this is a massive tangled mess.
So one thing I was hoping to be able to do is late initialize these things in DomUse. This doesn't solve the problem, and somebody has to fill this information, obviously, right? But if we late initialize them in DomUse, or have the option of initialize them later, then you could also do that from DOM0 if you wanted. I know this is not what Christopher is trying to achieve, but it gives another degree of option of where to do it, right? You don't have to do it in DomB anymore. It could be one other piece. So in other words, what if instead of being done in DomB, you want to do it in any other domain, even short-lived, but that is started in parallel? At that point, in order to solve the synchronization issue, I think it would be best if they could be late initialized. But this doesn't see. I think this is the minor part of the issue, because late initialize them is easy. The problem is who provides the information now. That's difficult.
Yeah, and another issue is if you want to late initialize, this means none of these domains is able to have a PV backend or something like that. So you might need to stage more or less the other domains, right? So the driver, So driver domains need to have physical access anyway.
Yeah, so I think this doesn't work if for boot. Yeah, so the way, as far as I understand it, it would work is you late initialize Grant Table in XenStore. Only after XenStore is up, you can discover front end or back ends. So certainly the back end are not going to come up until XenStore is up. When the backends come up, it's only then that you can use PV drivers also in the front end side. Right. Obviously, otherwise there is no front backends to connect to. So yeah, so that problem is there.
That means it should be created when the guest is created. So when only DomBs know what guest it will create. So DomBs are the information.
But DomB deliberately doesn't have tool stack permissions.
Yeah, I know.
That's part of the point here. DomB is basically sitting there just trying to do some initial measurements on the system.
Can DomB write some configuration data somewhere for other domains?
Yeah. Go ahead, Christopher.
I was going to say yes. I think that's totally reasonable. It's also not the case that you, if you're booting a system where having a control domain makes sense, there's no reason why one of your initial domains can't be a control domain. You know, we've got an example of it booting with an actual DOM0.
I'm asking because, for example, for the initial sensor entries, it would be rather easy to have to define a module format for XenStore stubDom, which is written by DomB for all the initial XenStore entries. So it's just more or less a text file, you could say. Just pair value, the name value.
Right, so basically you like doing XenStore ls, capture that to a file, and then pass that over to your...
So the XenStore stubDom, which will write those entries as wished, more or less. So XenStore entries would exist in the beginning for a starter, and this is essential for any PV driver to be able to connect, right?
The problem you've got there is still an order of creation what happens in the current design, at least, is that Zen creates all of the domains per whatever configuration we've got, which would include creating the the stub Zen store D domain. Right. Then DOM runs. So providing an extra boot time multi-boot option that's written by DomB to the stub Zen store is still an ordering violation.
But if you register an Argo ring in your Zen store unikernel, DomB can send you the config.
But
yeah,
then sensor D has to run before DomB is stopped, right?
So I think that's not a problem for this reason. So in order you could so this configuration for DomB, even without taking into account ZenStore, has to come from somewhere, right? And likely the user is not going to write it by hand, right? The user could write it by hand, but in practice it's hard, right? I get it wrong all the time for the zeroless. So it takes very, very special attention to be able to write it correctly the first time around. So there's going to be some tooling around it, some tooling to generate the configuration for DomB. If you have tooling to generate that configuration, you can also together generate a separate module to be passed to ZenStore, to be passed to ZenStore D. So you could generate them both from the same set of tools, and then you have both the configuration for DomB as well as for ZenStore D. I'm not saying it's a great solution. I'm saying that there are a lot of ways around this problem. The real problem is how to allocate the event channel, the grant table, and all that stuff.
Yeah, on the other hand, it's not too hard, because why can't the configuration contain the DOM IDs as well? So why do you have to rely on the hypervisor to supply the DOM IDs? Why can't you hardwire it into the configuration file? So the hypervisor would be very easily be able to create the grant entries and event channels up front.
Yeah, that's certainly an option. I think it would benefit massively if by default you could refer to them by a symbolic name and the DOM ID was randomized on boot, because what you do not want to have happen is the system that you bring up starting to make assumptions about which DOM ID is which. Because that's going to cause problems in the future.
Okay, no problem. But if you just say, have some virtualization in between, more or less, from the configuration file to the real DOM ID, the hypervisor can know about it. And then they create everything up front, and you can really just unpause the other domains from DomB and then die.
So the zeroless configuration today for the ARM side, and actually I've seen the one from Christopher, it looks the same way, right? There is a domains with the number of nodes underneath. Each node is for one domain, so you just need to link with one another. There are not even IDs at that point, but it's enough to provide references to the hypervisor to know which one is which. So yeah, I was hoping to be able to, my hope that without digging too much into the implementation was to be able to simplify somehow the problem so that it would be possible to do the event channel and grant table allocation in Zen without adding a lot of code, without basically just making the right calls and that's it.
To your point, Stefano, about tooling being used to produce this config, we're hoping that the initial boot blob that describes the domains you're launching might be simple enough that the bootloader itself could generate that from the config that you write. So your bootloader config describes basically the domains you want to bring up. So that would.
So in that case, your tooling becomes the bootloader, and your actual guest configuration is the bootloader config. So for us, the way it worked is so we're using U-boot, right? That U-boot is our bootloader. So U-boot doesn't quite have the equivalent of a grab.conf, right? So there isn't really a grab.conf with stanzas and config under each. So basically, it was down to doing some device tree editing and some loading. So it was a bit more difficult than writing not that writing grab is trivial, right? But this was maybe certainly safe to say it's harder to write. It was really not possible to do it by hand. I mean, you could do it by hand, but you will get it wrong. I will get it wrong 1 in 4 or 5 times, costing me hours to debug. So I wrote a set of tools that are online and public and open source. An evolution of the old ideas of image builder that we talked at one of the past conferences, and that it generates the U-boot script that does everything for you. So you might be able to get away without it if you use grub to do it.
All right,
but then
so,
you have to stick with grub.
Okay.
You cannot change it.
So to take a step back, so when we designed DomB, the idea was that you don't want DomB to be creating domains. You want DomB to basically take care of the higher order configuration of the system that we don't want inside of the hypervisor, because we want to make the higher order configuration is more complicated, will require complicated logic that we don't want in the hypervisor. The idea that it can do certain tool stack operations, hypercalls, is not outside of scope. What you want to make sure you do, this is why when I was originally proposing this back at the face-to-face or discussing it at the face-to-face, was that we want Flask in place, because if you have a Flask policy, that will prohibit the boot domain from establishing any communication paths that you might be concerned it might do or abuse. So if it can't create domains and you're able to restrict what data flows are able to be put in place by it, then you can make the a certain subset of hypervisor configuration calls from DomB to the hypervisor.
Very quickly, we are currently somewhat over time, and in the break and hallway chats, at the moment this seems to be going fairly well, so I think it would be prudent to continue if everyone is happy with that. We do have a hard cut-off in 20 minutes time when the next design session starts.
25.
No, I think the next thing should be at 1/2 isn't it? Yeah.
5 minutes.
Right.
GitLab.
5 minutes, right.
Yeah, 5 minutes.
Okay. Well,
Oh, those aren't in parallel. Sorry, I was misreading the thing that was clear in front of me.
but I'm going to be Daniel and I are going to be plugging away on this for quite some time. So if there's people have interest in this and want to talk after this, happy to do so. Please.
Yeah, we can grab a room later if people would like. Grab one of the breakout rooms.
Yeah, I mean, you can even schedule another design session if you want.
Something that may not be clear. I've definitely wanted DomB to be able to exit prior to any of the guests that it unpauses actually commencing work. It's a nice prop to be able to say that they never run concurrently. There's no opportunity for interference between the two classes of VMs. But I think it's going to end up being flexible enough that if you need DomB to continue running in order to do some live configuration of the other VMs, that's going to be possible too. But I am interested in any input or guidance on how to do a sort of atomic, exit of DomB and unpause of other VMs. Multi-call was a thing.
New DOM couple, I think.
Okay.
So in that, one of the things that we talked about that is being whether or not we want to be able to sequence that atomic startup, right? Because in theory, the hypervisor will start one at a time, all the domains. And so do we want the ability to control the order at which the hypervisor unpauses all the domains?
We don't have that in the zero lesson ARM today. I mean, not doesn't mean you shouldn't have it. I mean, it's just if we decide to have it, So one of the consequences today with DOM 0 less on ARM, you don't know exactly the DOM IDs beforehand, because the DOM ID get assigned by whatever is started first, and you don't know exactly who is going to be started first. So on 2 different boots, you might end up with 2 different DOM IDs for the same domain.
So why does it matter? Because DOM ID should not be static.
It doesn't matter, in fact. I mean, it doesn't matter because we don't have PV drivers. Well, it doesn't matter so far. That's all I can say.
But even for PV drivers, you should be able to read your DOM ID from the domain directly. You don't need to hardcode it.
So the problem, yes, absolutely, you're right. However, before the discussion, on how to populate the XenStore entries, in the XenStore entries, the DOM ID is written there. So somebody needs to, at some point, know the DOM IDs.
One other thing I'd point out on the sequenced start, it only matters to sequence the starts if you want to give some other domain the ability to continue the starts. So you pick if you shuffle them randomly and just start them bang in order, they'll all get their first time slice pretty quickly thereafter. The only thing that would be interesting from a sequencing point of view is have one run for a period of time and then unpause the next one, because you don't. If you need to sequence them, you're going to need a positive action from the first thing in the sequence to work out when the next one is. So either that involves every domain having unpause privilege on the next domain in the sequence, or you don't require sequencing to begin with.
My hope is that that's not going to be needed. Daniel,
I'd say you're probably more likely to discover and fix bugs by not having it sequenced.
So the sequencing issue comes up with the VTPM issue, which is you need to, especially if you want to be able to do measured boots within your guests, you need the VTPM to be present before the guest actually starts executing.
Why can't you pause the guest until it is when it hits that point?
What's going to unpause it?
Well, itself, when it finds that it's not able to use the device it expects to be there.
So one other option would be to change how we do the semantics of a missing device, because what will happen is it will trap on MMIO to TPM registers. We could change the semantics. So normally at the moment what we do is say there's no emulation here, hand back -1. Or discard writes. What we could in fact say is trap until set up or something like that. That might give you slightly finer grained sequencing.
Yeah, because in that way you're just yes. We're out of time now, so I don't want to.
Yeah, we need to switch over to the next session.
Thanks, everyone.
All right, thank you, everybody.